Because of the fact that we have a test in like a little over a week. I think it's next, well, actually is a week, on the 6th. So just realize that. So we got to get up to speed for that test. I have a little review in there. You should see it. It'll probably start in the next day or two for the whole chapter. But in the summer, you don't have a break in between classes like we do during the regular semester. So just kind of keep that in mind, because things are going to move really quick. So we got Chantel, I see, and Matthew, all people we had before. So we just got 3 folks out there. We'll wait a few minutes. But anyway, the thing we're looking at is set basics. And let me just kind of pose a question. How do we tell when a set is finite versus infinite? How can we tell if a set is finite versus infinite?
Whether it's well defined or not.
Okay, that's a different thing, but it's closely related.
Okay.
Let me trying to see what happened to my thing. I hate to go to the board. I got a little annotation thing in here. I don't know what happened to it. They hid it from me. All right, I'll tell you what I'm going to do. Okay, there it is. It only comes up when I share screen. I got it. All right. Let's talk about those. All right, and just remember the microphones on your end are voice activated, so I can. So if I mute you, it's not because I don't want to hear from you. It's just because there's background noise. All right. A well-defined set is one in which the description allows us to know exactly what is in it. All right. So let's give a couple of examples. All right. So that first one right there is, is that a well-defined set? Are we able to come up with a list of that?
No,
Why not?
it's not specific enough, I guess.
Yeah, that's basically what it is. And I'll just say, not well defined. The word smart needs to be defined further. Okay. So just one way we might fix this might change smart to all right. So if we wanted to make this well defined, we could fix it by saying the set of people in the world with the highest IQ. And then that's something measurable. We have to be able to measure it in math and science. Being able to measure things is important. We got a nurse out there, and we know that we can't just say, well, is the patient feeling better? We have to have some kind of objective measure. We'll go and check his blood pressure. We'll go and have blood tests. And there's a myriad of other tests that we use to be able to do that, to find out what their condition is. All right. So that's the way a well-defined set works. Now, Tori, you brought up well-defined when I asked the question about finite versus infinite. It's related, but it's not exactly the same thing. All right. So a finite set has a countable number of elements. So here's an example. Doesn't matter what's in it, as long as it has a countable number of elements in it. That set has 5 elements in it. We could also make one like this. Let's say we go 2, 4, 6, 8. And instead of keeping on going, we're going to do this little number. And let's say we go out to 30. Then that set has a countable number of elements in it. It has a ... because instead of listing 10, 12, 14, 16, 18, 20, 22, and so forth, all the way up to 30, we just establish the pattern first, and then we create an ending. An infinite set has an uncountable number of elements. So, i.e., let's say we do that same, well, let's try it with odds. So we got our pattern, and then if we keep on going without an end, then that is an infinite set, because this thing is just going to be all numbers that there are anywhere that we can come up with, which is an awful lot of them. In other words, it's infinite. You can always come up with another one. Let's say we go up to 99. That's an odd number. Well, there's another one after that. There's 101. There's 103. There's 105. There's 107. And we can always come up with another one, because numbers, just by their very nature, are infinite. So if we do not define it, and this is where it links into what you're talking about, Tori, with an ending and a beginning, or a beginning and an ending, then it will be infinite. All right. Does that make sense? Anybody got any questions? All right. Let's see if I can come up with something else we can do. I'm trying out this new whiteboard. I don't know if it works. I want you to join and all that. Oh, that's right. This was in the annotation, so I can keep using that same board. All right. So that's what we're dealing with when we're dealing with the concept of a well-defined set, and then how it links to also finite and infinite sets. All right. So did anybody have a chance to upload the photo ID?
Yeah.
Remember, that thing is, we're going to need to have all that in place for the coming test, because I'm sorry, for the first test, we'll just do it Zoom, but for the midterm, it's going to be in that respondus. So we got to establish identity. In also here, and I guess I'll just have to take all that out. All right, but also over here, let's say it's in the assignments. Okay, that respondus check, that's the verification for the 020, and then the photo ID. The respondus thing is it links you back to Alex. So over here, let me just see who we got. I'm going to try not to. Okay, good. Good. All right. Good, good. And it doesn't have to be a driver's license. You can use the Delgado ID. It's got less sensitive information on it, I guess you could say. So the good thing about the Delgado one is it's got the key stuff. It's got your picture and your name, and it's got a big picture. So the Delgado one is preferred, but the other one will work because you got to physically go and get one. And if you know knowing where to go, the police building or the police office, which I believe is in building, I think it's in the library building now on the main campus at Delgado West Bank. It's in the student center, the police office. All right. So the other thing is in Alex, this respondus thing. If you go to assignments, you can also access it through here, but it's right there, the respondus check, but it links back to this one. So with this one, you're going to have use the lockdown browser, and you got to have your webcam on. Now, here's the thing is, when you try to take this, it's going to say you don't have it installed, but at the bottom of that note, and let's see if I can bring it up. Let's see. Well, I guess it's letting me doing it because I'm a teacher. Anyway, I want to make sure that you've got the right one, because here's the confusion that we have in this class when we're using Alex. The app that you use is different. So when you do that, well, that's the instructions. I guess that's what one is right here. See this right here? All right. You can choose what you've got. All right. But here's the thing that confuses people. In Canvas, if you got a class that meets in Canvas and you test on their respondus, it's a different one. So just remember that this is where you want to come and get it, because see, it's for Alex in particular. So I'm going to put that on the browser. I'm sorry, in the addendum. Just in case it's not clear. So I'm going to put this right here. So that way, if you're going to get lost, know that it's here, and I can refer you back. Okay. So just remember, you need a different one than you would use in Canvas. So we are going to end the 120, do it slightly different, and I'll let you know as we get closer. But for this one right here, you need to have the one for Alex. So try to get those done as soon as possible. Okay, they're going to be open for a few more days. All right, so let's see what else we can get into. And remember, this is where I'm getting my notes that I go over a class with here. Right there where it says e-tags below the calendar. All right, let's talk about the difference between what's the roster method?
The elements within the curly brackets.
Yeah, we just list the elements separated by a comma. Okay. We can use the ... thing. Okay, that's allowed. Okay. So let's look at some examples. Let's see. We already kind of did, but so 1, 3, 5, 7. So there's roster method. Here's roster method. So there's a couple of examples of roster method. And then, of course, you could have just one that's got values in it. Okay. Those are examples of roster method. All right. Now, the other big one that we use is called set builder. All right. Well, how would you describe this one? How is that one different? Well, it's kind of hard to explain, so I'm not surprised no one's jumping on that one, because it's kind of a technical thing, but it's got a pattern to it. It is a format by which we describe the elements in the set. We don't have to list them all out. And it's a set format. In other words, it's got, so let's look. So let's say our set is A, That just means we read that as A is a set. The equal means is. And then we generally use X. You don't have to. You can use any variable. You use this right here. Now that part right there is the set part, the standard. And maybe I should have put standard format. Okay. Maybe that makes sense. And that just means when you open up the curly bracket, that means we're starting the set. And then it means X. And what that is, it's called a variable. Then that means that it can change. Like up here, our X would be 1, 3, 5, 7, ... on and on and on. So that just means that X such that X so the first thing I would put is a natural number, which just means it's all the counting numbers, nothing in between. And I'm going to do this one right here first. I can't really put in a, I'll come back and do it. Greater than 0, that'll do it. So that right there and the one here are the same. If I didn't mess anything up, those right there are the same. So it starts at 1. So 1, 3, 5, 7, on and on and on. So natural numbers mean there's nothing in between. So that's why we put X as a natural number. It's odd and it's greater than 0. All of those are greater than 0. And anyone inside, past the ellipse part is going to be greater than 0 because everything to the right is greater than 0. All right. Any questions about that? Let's see. Let's try this other one here. I should have labeled those up there, but we'll let this one be the middle one. Let's call it B. This part right here is always the same. Natural number. And there is a little symbol that means natural number, but it's not on the keyboard, but it's just like an N. Funny, fancy looking N. Now, this is where the set builder notation shines, okay? Because we can write that part right there fairly easy by using inequality. So what we can do is we can go put a 1 here. Well, I'll tell you what, we can put a 2. It's less than. I'm going to put 20 there, and that'll be the end of it. And then I'm going to come down here and just show you that you got a choice sometimes, and you got to watch this because we're going to add the equal sign because now it includes the 20. I'm sorry, the 2 and the 20. And the way this right here reads is, that reads as so that's what that means. It's between 2 and 20, including the endpoints. Now, I just want you to be aware that you can do this slightly differently without the equal signs, and it will mean the same thing. Because remember, up here, we said greater than 0 because we didn't want to include 0. We wanted it to start at 1. But we could do the same thing here. We could do 1. And then put 21 there. And that would be the same thing, okay? These right here are equal. Those are the same things. It's just two different ways of expressing it based upon what inequality is used, whether it includes equality or not. And then this one right here, just call it C. Same part. This is just the standard part. It just means X such that X is, and then you describe it. You can use many things you need there to describe it because it's natural. Now, there's no real pattern to these, so this is why where the set builder notation is not as helpful. If you can't write it with an inequality, oftentimes with the set builder notation, the explanation looks kind of silly. It would be easier to just do it like this. So set builder notation shines in some situations like these two, and it also can be used in a situation where it doesn't really make a whole lot of sense. Like I said, you might as well just have done it with us the roster, but you're just getting experience on going back from each one and the other. Okay. Any questions? Let's see here. What else we can get into? And remember, I record all these, and so they're available within a day of class time. And I put them in the 120 over here. These links right here are links to the videos. And you don't need a password here because I've uploaded them to YouTube so that they're freely available. These right here have the new recordings. Sometime today after we're finished, I'll put the new ones here. Okay. All right, let's look at something else here. All right. What about that kind of question? How can we answer that?
I guess I could try.
What's it? Yeah, give it a whirl.
If you write what 2, 4, 6, 8 in one
Okay.
set, and then the second set A, B, C, D.
Mm-hmm. And it doesn't matter what the elements are when we're talking about equivalence. It's just a matter of, do they have the same number of elements? And I'll kind of show you here. All right. what the sets have to have if they're equivalent is there's got to be what we call a one-to-one relationship. In other words, you can match up one in this set with one down in that set. So another way of looking at it is, let's call this one A. Okay, so then there's a thing called the cardinal number, and you use the N. Cardinal number is kind of a crazy term, but it just means how many, or the number of elements in B is also 4. Therefore, these are equivalent. All right. All right. Does that make sense? Is everybody seeing what equivalence is? It just means that they have the same number of elements, the same count. How is equivalence different from equality? I don't know. We'll just pose a question. Are A and B equal?
No.
No, because they do not have the exact same elements. They got to have the exact same elements. And order doesn't matter, neither does repetition. So let's look at this. Let's see, C, we'll call C. All right, are any of these equal to one another? Are any of those equal?
No.
No.
All right, so D is definitely not equal to either one of them, okay? D is its own. It would be equivalent to C for sure, because we just did that kind of thing up here, all right? Because
Oh,
they
wait.
both have
E are
the
equal.
same. But what about E? How many elements are in C? How many elements are in D? I'm sorry, E.
Then that'll be yes, right?
E has 6 and C has 5.
C has 1, 2, 3, 4, 5.
Oh,
But because 7
Okay.
repeats, it's counted as 1, right?
Yeah, the
Yes.
order
Oh, I
and
see.
repetition does not matter.
I remember that from yesterday.
me too.
Yeah. Okay, so that's something you want to hold on to, because that's something that you'll see and throw at you, is something will be repeated. And then when we get into a little bit later on, you'll see that it really works together pretty well, because if you take two sets and you combine them as one, if they have any repeating elements, then you don't count them twice the same way you do here. You only count them once. Since they are the same 5, they are equal. All right, so that's another kind of topic we looked at yesterday. Let's see if I can.
But
up
does
with
that mean
something
they're
else.
equivalent as well, or no?
Ah, yes. Okay. Let me put that up at the top here. Okay, so that's one of the important lessons to pull out of here. So that's good, Tori. That's, if two sets are equal, then they also going to have the same number. Because as I showed down here, C has 5 elements, and so does E, because we do not count them twice or more than once, let's say. All right. All right, let's see what else we can look at. And just remember too, so if you see that number, term cardinal number, that's all it means. There are other ways to, it's a tradition that's kind of stuck around. Cardinal number just means how many. Ordinal number, we don't really use that, but it's kind of fits with that. That's why it seems kind of like something odd, but there are other terms that have similar meanings, like ordinal number means position. And when we get to the end of the semester in chapter 11, the ordinal number, we don't really use that term, but when you take data and you sort it, you put it in order, you look for certain things in the position that they're in. So we don't need to worry about that now, but that's what ordinal number means. So it's cardinal number is not that strange of a term when you consider there's something called ordinal numbers, which has to do with position. All right. So here's something we can do. I'm going to come back and put it in there, so I don't think I'm leaving it blank on. So in math, it's quite common to use shorthand symbols and such. It looks like that little pitchfork thing, like an E. In the notes, I've actually got it typed out, but see that? I got it real big right here. So that just means X is an element of A. And if you draw a line through it, it means it's not an element. Okay. All right. So what I'd like you to do with the next 5 to 10 minutes is I would like you to upload, if you haven't done it, upload your ID. You can have the time to do that. And then if you'd like, you can go into the Alex and do this little thing. You'll have to download that, this right here. So you can work on that. It's not got a whole lot of questions in it. It's just a couple of little silly questions. Hopefully they shouldn't be a stumbling block to you. But the main thing is you got to download that and install that app for the Respondus browser. So what is it called? Respondus check. And then for the next 15 minutes, I'll come up with something else for us to do together. But that's what I'd like you to do. I'm going to pause. Do you know where to find those things? Does everybody know where to find those things?
Yes.
Because if you go to assignments as a student, it looks slightly different than mine. And I may have trouble finding it too, but it will definitely be here under assignments. If you go into assignments, it's right there at the top. And you can get both of them assignments, but I think this one is under, might be under, yeah, it's under assignments. And this one goes back to the Alex. So I give you 15 minutes to do that. I'm going to pause the recording. Okay, so how can we tell if a set is empty or what's also called null? Here's a description. So for this right here, the set of natural numbers less than 0. Is that set empty, null, or are there elements in it? Now, it's kind of a little bit of a stumper because you might not be used to the term natural numbers. Remember, natural numbers just means the counting numbers starting at 1, 2, 3, 4, 5, 6, and it keeps on going and on till infinity. So, is it possible to have a natural number less than 0? Well, no. All right. And we represent the empty set either as this, just open and close with nothing in it, which kind of just very intuitive way, or, and I got to draw a line through it. Either one of those can be used to represent empty sets. Okay. And you kind of got to just have to be on the lookout because sometimes the way that things are described, you may not quite understand all the terms. So you just want to investigate a little bit because the key to this is the term natural numbers. And it's impossible for a natural number to be less than 1. Actually, you could, even 0 is not a natural number. Those when we add 0 in, it's called whole numbers, and then when we throw the negative ones in, it's called integers. Let me see if I can find something real quick to finish the session up. Oh, and if since y'all are in the 020 class, if you're upset by the fact that you don't have a real textbook, you just got mine. Well, in the 020, there is an e-textbook that's a professional looking one. So see this? And like, for example, if we want to go to set 3, you go to chapter 2, and then you just go down through the topics. That's not what I want. Let's find a problem that's got an empty set in it. For some reason, my brain's not coming up with any good ones. So cardinal number is just the set of elements, the number of the set of the elements in it, the count. And it's usually read like denoted like this, and that just reads as n of a. N of a. But it's the same thing as cardinal number. All right. So if the n of a is empty, is nothing or 0. I was trying to see if they had a problem in here. I guess I'll just go to the end. Let's see if there's something in there. Because those are kind of rare problems. I mean, I came up with one of them, but you just kind of have to use something. It'll become more evident in chapter 2. I mean, in section 2, the need for the empty set notation, because when you're comparing two sets, you can look for common elements. And if there's no common elements, the set would be empty. So here's an example. Like I said, is you almost have to use silly ones in order to get an empty set at this time. When we get into 2.2, it'll make a little bit more sense. But this tells you X, and that's crazy set builder notation. X such that X is a living Stegosaurus is an empty set. All the Stegosauruses are gone, or they're all dead at least. All right, so that's probably enough. Like I said, there's not really much to say about the empty set at this point, just other than realize that that symbol, the little slash through it, or the open and close curly brackets without anything in it, means empty set. That's the main thing to know at this point. All right, so I'll stick around here for any questions you may have. Otherwise, I'll see you at the bottom of the hour, 12:30, for our 120, and we'll again take questions, and then we'll go on to 2.2. So if you need anything, just yell. All right, stay around here for a few minutes until 12:15. Otherwise, I will see you about 15 minutes, 20 minutes. Are you okay, Alonza?